In this brief lecture, we're going to learn some basic facts about using volumetric flasks in the analytical laboratory. Volumetric flasks are calibrated to contain a certain volume of solution at the temperature indicated. Here we see the flask is marked TC 20 degrees Celsius, meaning that it is calibrated to contain pretty close to the target value of 500 milliliters of solution when held at 20 degrees Celsius. This is in contrast to a volumetric pipette, which is calibrated to deliver a certain volume, as indicated by the TD marking. It is impossible to calibrate a piece of glassware to contain or to deliver an exact volume, so we need to know how close these volumes will be to the true value. If you examine your glassware the next time you're in the lab, you should be able to find an indication of the equipment's tolerance, or the maximum amount of measurement error associated with the volume contained or delivered. For example, a 10 milliliter Class A volumetric flask will contain between 9.98 and 10.02 milliliters of solution at the calibration temperature. A less expensive volumetric flask may only be rated as Class B, meaning that the maximum amount of error would be twice that of the Class A flask. If you'd like to read further on the topic of tolerances and glassware, I'll post a link to the Measurement Errors article in Libre text for your review. What information can we gather from this piece of glassware? Before you use your volumetric flask for analytical laboratory work, you want to make sure it's been cleaned appropriately for the task at hand. Typically, we'll be working with metals or compounds that react with metals, such as EDTA, so you'll want to acid wash the glassware to make sure you don't leave behind any trace metal ions adsorbed to the glass surface. This is not to be confused with the process of absorption, meaning that the metals are taken up by the glassware like a sponge. That's not the issue here. To prevent cases of adsorbed contaminants on the analytical glassware, do not store chemicals in the volumetric glassware for extended periods of time, like the entire semester. Finally, you want to use the volumetric glassware to your full advantage. This means that you'll dissolve your masked reagent in a small amount of solvent first by swirling it vigorously in the large bulbous end of the flask. Only when you've gotten the solids to dissolve do you want to fill up the volumetric flask into the neck. When you're approaching the calibration mark, be sure to switch from filling the flask with a carboy or squirt bottle to using a dropper or a pipette. This will give you much better control so that you don't overshoot the mark and have to start over again. Once you've completed this process, then you can invert the flask several times to ensure complete mixing.